Okay, so as we know, we are going to work on graphical user interface, or GUI, which is like a mini software that you can write in MATLAB, and it allows a graphical way to communicate with the user instead of directly writing code. But you have the responsibility to write the code to run this GUI behind the scene. So GUI in MATLAB has a bunch of different options, like push buttons, sliders, checkboxes, edit text, static text, toggle button, list box, panel, axis, and so on, that we can add and we can activate them. And as you learn, each GUI has two files. One of them is this surface or facade kind of file that you make, which we call it .fig, right, the figure file. And you can change the colors, you can get the names, tags, strings, and so on. But really, if you put these elements inside your GUI and click on the run, nothing is gonna really happen, right? Because behind the scene, you have to have the code written for each one of these objects. Most of them have what? A function. So whenever you, let's say, push a push button, or type something, let's say check a toggle button or move a slider, they have a function most of the time, not all of them, but some of them do, that will be called. Most of the time, will do it through a push button, but that's not the only one. And as we saw last time, and we're going to work more through it today, most of these stuff that you can communicate to, they have one or two functions that you use a lot. One of them is get, to get a value from them, and the other one is set, to put something on them, to display, show, and so on. So the example that we started last time, if you remember, was the projectile example. So the goal of this example is you launch a projectile from initial point of x naught and y naught with a launch velocity of v naught and with a launch angle of theta. And you know, if there is no air drag, this projectile will follow a parabola and would ultimately what? Hit the ground, and then this range for projectile can be defined, which is from the beginning point to the end point. So we call this what? Range for the projectile. And if this launch is happening at time of 0, whenever it hits the ground, we call it what? Flight time, or here TF. And so the goal is the user will give you the values for x naught, y naught, theta, and v naught. You give it back the range, the flight time, as well as what? An animation of the ball moving on this projectile, okay? So that was the goal of making this GUI. As I told you, in order to make a blank GUI, make a GUI from scratch, or open an existing GUI, in MATLAB, you type in the command guide, and it will bring here, well, you can create a blank GUI guide, you can open existing ones, right? And if you remember, last time we made this, so let's take a look at it. So here we have this projectile simulator we made last time. What I have here are 4 edit windows. This guy, edit text, in which you can type a number and you can use it as an input. You can write code to read the numbers that you type into them whenever you run it. Then we had 2 static text. These guys, you cannot read from them, but you can write to them some string, so they act like a monitor. And this range and this flight are basically monitors. And then to make it more organized, we basically put, so here, this is another way to organize this stuff, align them, right? Oh, no. Not that, of course. So if you go here, horizontal alignment, and it should be this guy. Wow. Oh, it's vertical alignment, that's why. So there is something wrong. Vertical alignment. Isn't it this one? Should it be? Gosh, it's not doing any of that. What's going on here? Well, all I wanted to do is to move this guy to the center and then this one right below it. But we put each one of these guys on a panel so that they are more organized and we can move them, resize them. We had an axis that you can create a graph, and then we have a push button which you push to run everything. And as I said, if you click on the run, this is the .fig. It is going to give you this basically mini software. Now you can click here and provide some numbers. Let's say I launch it from the origin, and then my launch angle is 30 degrees. The launch velocity is 100. So if I click on this simulate, I need to first come and run, get this data from here, do my calculations, and then type the result here and show the simulation there. And if you remember, the equations that I need, if you remember, is what? So we have range, which was V naught squared sine of 2 theta divided by g. And then I have the flight time, which was V naught times sine theta divided by g. Both of these are assuming that, basically your y naught is 0. So you're going to launch it from the ground, not launch it above the ground. If it's above the ground, this formula is not going to be this simple. So here, if we assume that's the case, we can use the simple formulas. Otherwise, we have to do more calculations, which is not really that hard. It's just finding the roots of typically a quadratic equation. And the equations for update of x and y, if you know versus time, x is initial x plus v naught cosine theta times t, and y is initial y plus v naught sine theta times t minus half of gt squared. Okay, and we keep simulating until what? Y is bigger than or equal 0. When it hits 0, then we have to throw the rest of the data away or stop the simulation. So this is the goal. Now, if, as I said, look behind the scene, when you create this GUI, if you click here on this guy, the editor, it shows you the code behind the scene that you have to write and modify. And by the way, as I told you, each one of these guys that you drag out here, you can double click on them. It brings this inspector window where you can change the color of them if you want. You can change the font size. You can change the font type, normal or bold. You can do lots of things. You can change the string that is shown on them, correct? And most important one is the tag, which is like the name of that guy, okay? So for example, the name of this is called push button 1. So now when I click on this, everything should happen. So whatever code that I write, I should write it inside the function for push button 1. Now these GUIs are typically long code, several hundred, sometimes several thousand lines of code. And instead of me scrolling up and down looking for push button 1, I simply here go to this guy says go to and look for what? Push button 1 callback. This is the function that will be executed when you click on that push button. Now here, this is the code we wrote last time. What did we do? When this button is pushed, I go to different blocks, but not all of them. For now, I first go to what? the block called edit 1, edit 2, edit 3, and edit 4. I go to them, and then I get from them what? Whatever the user typed, I get those values from them. I get them as a string, but I cannot use the string for these numbers, x naught, y naught, theta, and v naught. So I convert them into number by the function str to num. I convert my string into a number. And again, edit 1, 2, 3, 4 are these guys, right? So if you click on them, this is edit 1, edit 2, 3, and this last one is what? Edit 4. So the first thing I'm doing, I'm reading these 4 numbers that you typed. That's the first thing I do. Then for my simulation, I clearly need the value of g. So I type it in directly. And now, again, assuming that, as I told you, assuming that y naught is 0, I can get the values for r and tf through those 2 formulas, and I can now directly show them onto those 2 windows here, this one and this one. And their names, again, their tags are what? One of them is text2, the other one is text3. So I go there, and now I say, well, set the string for that text2 or text3, one of them to be what? The number I found for range, but they are going to show a string. This is right now, it's a single number, double format. So now I convert the number back to string and now show it on text2. And I convert tf into string and show it on what? Text3. So right now, if I simply run this and type some numbers here, so let's say 0, 0, 30 degrees, and what? 100 meters per second, and click on the simulate, it should be enough to give me the range and the flight time, right? So that should be enough for that. Okay? Now, here, one thing bad is, well, these numbers are shown here, but I don't know which one is which until I go back and say, well, the top one was range, the bottom one was flight time. So either make these strings that you are showing here a little bit nicer, like add range and flight time to them so they are showing what is what, or add a separate string here, another window like that. So make it like 2 of these here, look. One of them you do not change, leave it as r equal, the other one you update, okay? But I prefer here to stick to what? One of these, just make them big enough to show all of the details, but since the fonts are big, I'm gonna go back to a smaller font and make sure whatever I show in them has enough of information. So here, I make them a little bit longer. And now, when I want to update the text in them, what do I say? I'm not going to say simply num to string r. I try to concatenate another string with it, and that one is what? R equals number and string, right? So here, this is one string, the number r converted to string, and here is just this pure text. And I put them together by what? Concatenation, correct? Put them next to each other. And here I say what? I say the flight time is equal to that guy, right? So now hopefully the string I'm showing is a little bit what? More informative. So let me run it again. By the way, you can run your GUI either by running the code or by running what? The figure. Any of them would do the job. So here, let's do it again. 0, 0. Theta is 30. The V is 100. So hopefully now I have something nicer. Okay? So this is first working with edit text and static text. So far, any questions? Now let's take a look at how we handle what? The animations. And as I said in the lecture, I have provided you with commands that you need to what? Communicate to a toggle button, to a static text, to basically doing a picture here, the axis that we need right now, and then the edit window, the checkbox, and some other things that you might need. And then the most important one that we'll see later, sharing data among different functions. So right now, as I said, what we need is to first say which graph, which axis we are going to do the plot on. You have to provide the name and then do whatever we want on it. Okay? So we need something like this in our code. So now let's say this is the animation. I say do it on axis 1. Now, is the name of it axis 1? We can check. And it is. You can see it. But if you go down and find the tag, you see the name is axis 1. Because many times you might have more than one axis, okay, on the same GUI. You might have several of them. So yes, the name of it is axis 1. Fine. Now what should we do? We have to, of course, calculate what? X and Y as a function of time, which I showed you, and then plot them and also do what? Animation. So the first thing I need is to create a vector of time values, t's. So let's do it. So before I do animation, I need to do some what? Calculations, of course, correct? So first I create a t, and I say t goes from what to what? Let's say it goes from 0 with some time increment every 0.1 of a second, go to what? 100 seconds. I try to overestimate my flight time. Now, in this case, how much was it? Do you remember? How much was that? For this case, 5 seconds. Really? Okay. So I'm not going to go too far, maybe 10. And here I have a bunch of data points. And now I say what? X equals X naught plus V naught times what? Times cosine D of theta divided times T. Correct? And you need to make sure you are using functions sine d and cosine d because the theta we entered is in degrees. So that is my x. Then y is what? Y naught plus v naught times sine d theta times t minus 0.5 times g times what? T vector squared. Correct? Make sure you use dot power. So now I got my x and y. And now if I want, I can do what? First, the plot on that. First, let's do plot, then we do animation. So here, plot and animation. Now, if I plot it, do you see anything wrong before I do the plot? Remember, this time is more than the actual flight time. So what happens to the x and y? Y continues to go what? Negative now. Right? It's like it's going below the ground, which is not going to happen. So first thing is I need to trim the portion of y out where y is negative. How can I do that? You remember, we use logical operators and say y where y is what? Negative is equal to what? Empty brackets. Correct? Or if you want, you can say what? You can do another thing. You say index is equal to find where y is what? Negative. Find which indices for those y is negative. Then what? X at those indices is equal to empty bracket, and y at those indices is equal to what? Empty bracket. Remember, if we assign a portion of an array to empty bracket means eliminate it. So here I am eliminating those portions of x and y for which y is negative. So now hopefully it only continues to the ground. Now that I got it, I say go to axis 1 and then what? Plot x versus y, let's say with color red, for example. Right? Yeah, so far? Now let's run it, see if it works. So 0, 0, 30, and 10, or 100. Boom. It is working fine. So another advice is, if you want to do something, do not write it all the way to the end and then start testing. Never do that. Every portion you write, test it, make sure it works. Because otherwise these errors accumulate, okay? Now, for example, what do you think it's good to add here before I move any forward? Tell me. What's good to add? X label and Y label, definitely, right? We don't know what is what. But if I want to do that, that X and Y, especially Y, is not going to show itself because this input window is on the top of that. So what do I need? I need to go back here and maybe move this guy a little bit this way and move this guy a little bit. But there is no room until what? I expand my window a little bit, like this. Now, hopefully, I have what? Enough room for it. So I save it. I go back to this code and say, not only do plot, I also want you to add what? An X label and a Y label for me. And maybe a title, or maybe not for the moment. This is one thing. What else do you see I can improve here before I do anything else? We made some assumption that is good for y of what? Y naught of 0. What if the user decides to use a y naught that is not 0? Then what? What happens? Then these two equations are not going to be valid. But I can calculate these two guys by a different method. How can I calculate them? Well, if you remember, what I'm doing here is I'm finding where y becomes what? Negative, correct? So this index, let's say if x has what? How many points? T here has 101 points. So x and y have 101, but a portion of it is going to be thrown away. Let's say 40 of them are out, so 61. So x and y, each one will be 61 after we trim them. Now, how can I find the range? No, I can if I want to. No, yeah. I wanted the time step to be constant. When you say linear space, the number of points are controlled, not the time step. If I say 100, what happens? If I say t is linear space between 0 and 10 with 100 points, how much is the time increment? It's not going to be 0.1. It's a little bit bigger than 0.1. If I say 101 points, then yes, it's equivalent to this. Okay, so it's important whether you want to control the increment or the number of data points. Here, I care about the increment, so I use this column operator. So, okay, I got this, fine. Now, can I find that range and final flight time now that I know where y becomes negative? For sure. Why? Why is that? I don't even need to go there. Well, what is range? What's the definition of range? It's the largest x, the final x that I have minus what? The initial x. That's range. And what is the flight time? That's the final time I have before y becomes negative minus time of 0. Correct? So I can do it after I'm done with this trimming. So what can I say? Instead of these guys, which have assumptions, and I'm not a fan of assumptions as much as possible, so what do? I will come down here, and I try to avoid the assumption, and I say, so these are the monitors, or the static text. Oh, what happened? Here, that's fine. So I calculate the range here. I say range is what? The biggest x. Where can I find the biggest x? X end, correct? The last x. Minus what? x naught. Agreed? And what about the time? I can say the flight time can also be what? T of end if I trim t. Here I didn't trim t, but if I want, I could trim what? The t as well and get rid of the portions of time for which y is negative. Correct? And you know, t initial is 0, so that's good. That's flight time. This is what? The range. And now this guy does not depend on me to enter y naught as 0. Y naught cannot be 0 now. You can launch it above the ground. You see? So always try to improve on it. And here, let's do it. So to test it here, I'm going to make this 1 or maybe 10. Let's change it. I make this 45 degrees or 30 degrees. And I made this like 100 or 80 or whatever. And simulate that. And now I have the flight time. I have the range. And I do have the plot, which clearly you see it is launching from 10. And if you look at the range, it is what? 575. And if you look at the time, it will really be 8.3 seconds. Okay, so this is way better than using a formula that has a bunch of assumptions in it. Okay, so I'm not going to use that. Good. So I got that to work. What is one more thing I can make sure? So here you see, I changed my angle and velocity, and my endpoint was very close to this 10 seconds. It was 8.3. Had I made the angle a little bigger than 30, like 45 degrees, probably the flight time would be bigger than 10. And so this trimming is not going to work, and your projectile probably would never hit the ground. So you want to make sure that you run the simulation for large amount of what? Time. So maybe instead of 10 seconds, I run it what? For 50 seconds, for 100 seconds, right? And it doesn't matter because here, whatever portion of it for which y is negative is going to be thrown away. So always overestimate your flight time by maybe an order of magnitude, correct? To make sure the simulation continues even when y is negative. Now that I got all that, it's time to do the animation. How do we do animation, if you remember? So we first plot the first point of the projectile, x1 and y1, and we put something in there, let's say a blue circle, correct? And we can fill it. Anybody remember how to fill the hollow blue circle with completely blue color? Excellent. Marker, face color, and it should be also what? Blue. So now it is going to be a circle blue, completely also filled with blue. I plot it at the first point, and I get the handle for that picture H, or I can say H of simulation. And then I use a for loop where I goes from 2 to what? To the length of t. And each time I update my x data and y data of the graph. So the hsim handle, I updated with what? X data. Instead of being x of 1, I make it what? X at this current location, II, right? I update the x data. I update the y data with the current y, and then I say what? Draw now to update it. And if it's too fast, I use some pause to slow it down, correct? So now the underlying curve is going to be red, but a blue solid ball will move from the beginning point to the end point on this graph. Yes? And since I don't want this new plot to override the previous plot, I have to also say what? Hold on, right? So they are on the top of each other. If I don't want this red to be completely solid, I make a dashed line by this. And let's run it now. So here we go. 0 maybe, and this is like, or let's not make it 0, 5. This is 10. This is 45 degrees, and this is 100. Yes? And here we go. Okay, and that's what you can call your own mini projectile simulator. Okay, any question on any of it? Good. So far we have learned how to communicate at least with 4 types of blocks: the static text, the edit text, access, push button, and then bringing a panel and basically putting all of these buttons, let's say, on what? On the panel, so they are grouped together and I can move it. For a panel, there is no code behind the scene, so it's just for organization. Okay, so this is the first step. And we talked about it. Now, as I said, there are other things we can do. One of them is the checkbox. The other one is a slider and a toggle button and other things. Let's, for example, deal with the slider, okay? How can I get the value out of a slider, which is shown here? So we can build on that projectile, right? What do you think? Yeah, maybe the speed of animation, huh? Maybe the speed of animation. If I move a slider, it makes my animation what? Slower or faster? Yes. True, but what does it have to do with the slider? If I move a slider left and right, I want it to modify something. No, it's not a slide the bar. It's a slider below the graph that if you move the left to the right, it changes something about your outputs of the GUI. It changes some parameter in your GUI, some output parameters. Not showing the velocity at each point. I can add that to the graph. It's not a big deal. But I want to add a slider, and by moving the slider to the left and right, I modify something about the performance here. Say it. The angle, you can do that. You can do that too, sure. Any of these parameters, if you want, any of these, you can use a slider for. But here, since I have the inputs for this, the only thing I don't have control as of now is what? How fast the animation is going, correct? So maybe this time here, this guy, this 0.1, I want to bring it from what? A slider, and that allows me to make the animation slower or faster. So what I will do is I come back here, and now this time I'm going to bring what? A slider, which is next to the push button. I bring it, and I put it down here. And I move it so it's horizontal. I make sure my GUI is big enough, the background. It is. So now I have this slider. If I want, I can change the color of it or anything, right? So feel free to change it to anything that you want. Change the font of it, change anything that you want. And maybe here I provide a static text to say what this guy is all about. So maybe I go here, and then inside this, I say, well, this guy is about what? The animation speed, right? So I make it something bigger, make it bold font, and then in the string, I say this is the animation speed, okay? So they know what they are controlling. The other thing that is important is when you move this guy left and right, what is the smallest value? What is what? The largest value, okay? You have to have control over that. typically by default, if you don't set it, the range is between what? 0 to 1 or 0% to 100%. But maybe your animation does not need 1 second of delay or 0 second of delay, right? So you can scale it up or down, whatever number you get from that. And you should also have control here to change the range for it. Do you see anywhere that you can change the range? Here, right? Min and max, right? So you can change it. Instead of 0 to 1, let's say the smallest delay pause that I want to have is 0.01, and the biggest I want to have is what? Maybe 0.5. This is too slow. 0.01 is rather fast. So what happens? Now, between 0.01 and 0.5, anywhere you put it, by a linear interpolation, it will give you what? The corresponding value. So you can set it anything that you want. Right? So now if you want, you can show also those two values on the left and right so they have an idea. So maybe I do something like this. I say it is between 0.01 and I give it some space and then what? 0.5, something like that. Or let me get rid of this. So here, now if you make it bigger, it probably, right, gives you an idea of which range you're talking about. Okay, so now I got everything under control. Now I want to go back to my code, get the value whenever I move this, and use it for the pause. So everything is happening under what? Under the push button. And I'm going to go to the push button. Here. No, the push button. Here. And here I used pause of 0.1, but this time I'm going to get the value of pause. So how? I say, well, this pause P is equal to what? Get of handles and, right, as it says, you have to get the name of the slider and then get the value. So you have to know what's the name of this. And it should ideally be slider 1 because it's the first time you brought it in. And it is slider 1. So you can get the slider 1 value. And the other interesting thing is when you get a number from a slider, it's not going to be a string. It is going to be an actual double number. So you can directly use it. So now that you get p seconds of pause, here instead of saying pause of 0.1, you say pause of what? P seconds. Yes? So now it is under your control. And you save it. Now let's run it. 5. Oh, it's interesting. It's not showing here. Okay. Now one reason could be it's so low down here that it's not showing it. So one thing I can do is shift everything up a little bit. Still not showing. That is very weird. Let me just put it there, just for testing. Wow. Okay, that is not good. Okay, let's see. Says the slider cannot have a value outside of min-max range. Gave me a warning. A value outside min-max range, and it's not going to be rendered. Okay, so it is telling me what's going on. So it seems like when we messed up with min and max, something was bad. List box top 1.2. Okay. Put it at 0.2. Let's see now. Oh, no. It's probably somewhere I'm setting some number out of this range. No, it's not list by top. It's like the default position or something that it does not like. Oh, 0. Right. That is where it should change, not this guy. This guy could go back to 1, I assume. This is the default position. Okay, so you have to make sure when you modify stuff, there we go. Right, this is the default location that is here right now. You have to make sure, otherwise it is going to pick on you. So here, 5 and 10 and theta of 60 degrees, maybe initial velocity of 120. And here I can change this number. And let's first make it quite slow, right? And do the simulation. Definitely see it is slow, right? Now let me stop that. Okay, let me close it. Run it one more time. 0, or let's say 5 and 10. Theta is 60 degrees. This was 120. I bring this guy down, make it very fast. And now do it. And now it should be a lot faster.